Okay, so we're going to skip the warm-ups for right now. We did this in class. And we're going to go straight down to 5.6 notes, where we talk about the law of sines. You're going to want to memorize this. The law of sines is used specifically when you do not have a right triangle. That's the big thing. When two angles on the side are given. Okay? So it's a proportion that exists. And basically, it tells us that the sine of angle A divided by the side length A is equal to the sine of angle B divided by the side length B, and sine of angle C divided by the side length C. And so with this proportion, you can find any of your missing side lengths or angle measures. The Pythagorean theorem is only good for a right triangle, so we can't use the Pythagorean theorem anymore. So the first thing I want you to do when you're looking at these examples is I want you to actually draw the triangle out with all the information that's given. So on this first one, we're going to not draw a right triangle. We're going to label it A, B, and C. We're going to put angle A as 33 degrees, B is 105 degrees, and we know that angle C is going to be 180 minus 105 minus 33. Which is 42 degrees. And we also know that side length B is 37.9. So the proportions that we can write then is that's sine of 33 over side length A, which is not given, is equal to the sine of 42 over side length C, which is not given, and that's equal to the sine of 105 over the side length of C, which is 37.9. And this part right here is going to be our scale factor, and because everything is given, we can set this fraction equal to this one and individually to this one. So in other words, the sine of 33 over A is equal to the sine of 105 over 37.9, and the sine of 42 over C can also equal the sine of 105 over 37.9. So cross multiplying and solving for your lengths, A and C, gives you that A is about 21.37 and C is about 26.255. So it's a nice little formula to know so that you can find missing lengths in a triangle that no longer is a right triangle. Okay, so the next one tells us we're dealing with triangle LMN. All right, LMN, 29 degrees, 112 degrees, and now this one missing length or angle measure is 39 degrees. And so we know that side length L is 22. And so our proportions that we can say is that the sine of 29 over 22 equals the sine of 112 over M, which equals the sine of 39 over N. And again, solving, I think that M was 42.074 and N was 28.558. Do the math. Area of a triangle if it's not right. Well, notice in this case, AC is given and BC is given. These are side lengths, and angle C, which is 57 degrees, is given. This is an example, if you remember from your geometry, of side, angle, side. Okay. And so basically, to find, I'm going to show you the hard way, and then we'll talk about the formula. The hard way to do it is to understand why. To find the area of a triangle, we know that area is equal to 1/2 base times height. But the base, if we draw our height this way, we don't have the height. It has to form a right angle, and we don't have any right angles in this triangle. So when we draw our height, we want to make sure that we drop it down from a vertex to a side where the side length is given, and we don't cut into the angle that is given. It's because we drew it this way, we don't have any angles to go off of, and we don't know how the 57 degrees is divided. So using this triangle right here, we can say then that the sine of 57 degrees is equal to h over 66.8, and that gives me that my height is 5.703, if my math is right. And now, if my area formula is base times height, the base that we have to use is what we drew the altitude down to, which is side length AC. So we're going to say 1/2 of 9.3 times the height that we found, 5.703, which I think is 26.519 square units. Okay. All right. And so we would do it again for this one. The big thing was just converting that into an angle measure that you could use that didn't have minutes in it. The formula that you actually have is given a triangle, and this is only going to work for side angle side. Okay, if this is triangle LMN, if you're given angle M and side lengths L and N, that the formula is the side length of L, side length of N, times the sine of that angle. So we're using side, angle, side. So divided by 2 gives you the area. If you are given angle N, in this case, then the corresponding sides that have to be given for us to use side angle side would be this one and this one, which is side M and side L, and that's how they're getting, right, yeah, so that's how they're getting L times N times the sine of N. And so my last, divided by 2. And so then my last option is going to be that if I am given, here I was given M and N, so that means I'm given angle L. If I'm given L, then I have to be given these two sides to be able to use a side angle side. And we'll say that the area then is equal to side M and N times the sine of angle L divided by 2. So it's a nice little formula to use. You can memorize the formula, or you can go through the process of the other 2 examples to find the area. So remember that we want to use side angle side for these formulas. So give a triangle ABC with C being 4, A is 37 degrees, and angle B is 69 degrees. This is not side angle side, this is angle side angle. But if I find this side, I would have a side angle side triangle. I'm given this one, here's my side, here's my angle, here's my side, and I can go back and use one of these formulas. So we're going to go ahead and use the law of sines to find the corresponding side length to angle B. And we say then that we know that this angle, if this is 37 and this is 69, that 180 minus 37 minus 69 is, let's see, .78 degrees. And so I can say the sine of 78 divided by side 4 is equal to the sine of 69 divided by side B, which I'm looking for. So then B is going to equal 4 times the sine of 69 divided by the sine of 78, which is 3.818. And so then we'll say, well, using this formula up here, this is our middle angle, these are the corresponding sides, we'll say that the area is equal to 4 times 3.818 times the sine of 37, all divided by 2. And so when we do that, we're going to get 4.595. So the area And I'm doing this a little bit differently than the notes, the Moodle notes that don't have the voice record, but that's okay. Okay. All right, so the same idea on this next one. I don't remember how I did it on the notes, but I lost the voice recording, so I'm recording this over. But we're going to use this method again, and we're going to draw our triangle A, B, C. 85 degrees, 14 minutes. B is 19. Side A is 2. If I want to have the side angle side, I need to find that side first. I know that angle A can be given to me also, and I need to know it because that's the side that has an angle, that's the angle that has the side corresponding to it. So if I do 180 minus 19 minus and 85 degrees 14 seconds really is 85.233. So 180 minus 19 minus 85.233 is 75. So this is what C is. No, this is what A is. It's 75.767. And so then area is going to equal, no, can't do area yet. Now we have to find our missing side length of B. We can say the sine of 19 over side length B is equal to the sine of 75.767 over 2. And so 2 times the sine of 19 divided by the sine of 75.767 tells you that this is B is about 0.672. So this is 0.672. So now the area is going to equal 0.672 times 2 times the sine of 85.233 all over 2 times the sine of 85.2, and we got about 0.669 units squared.